Hello, welcome to Introduction to Django Ninja. My name is Vitaliy Kucheryaviy, and today I'm gonna show you what Django Ninja is and why you should use it. So I work as a software developer for almost 20 years, and most of the time I use Python, and major part of that I usually somewhere near Django code. You probably noticed that I'm not at the stage at the moment. Well, that's because Russia invaded my country, and I'm personally from city Kharkiv, which is shelled almost every day, and almost every day we get casualties. But I would like to thank DjangoCon Europe team and everyone who listens now for this amazing opportunity to present my talk. I really appreciate it. Thank you. So what is Django Ninja? So it's a relatively small library on top of Django that uses type annotations to create REST APIs. This project is heavily inspired by a framework called Fast API created by Sebastian Ramirez. So the secret sauce here is pretty simple. We take type annotations for describing APIs. These annotations are validated using Pydantic, and all this runs and integrates deeply with Django framework. Let's quickly jump into type hints, or also known as type annotations. So let's look at this function, right? So yeah, there is two arguments, and the result is the plus operation between them. And we cannot really know what are the A and B here. Are those numbers? Are those strings? Or maybe these are just some kind of remote data frames that happen to implement the plus operation. So to help us here, we can add annotations. Yeah, they are defined with the semicolon and the type of this argument and the result. And here we can now understand, yeah, that the arguments are two numbers, and the result of this operation will be also a number. And if we run it in interpreter, yeah, like so far so good, we added two numbers, we got the result. But if we run a pass, there are not numbers but actually strings. Yeah, there is no errors, there is no warnings. Yeah, we got the result, but and again, the result is not a number, it's a string. So as you can see, the type annotations, they are not involved in runtime at all. These are just hints that can be used by linters or by editors. So for example, in VS Code, if I mark one of the arguments as int and other as string, you can see that now I got the warning that the plus operation is not allowed, and it will eventually throw an error. So as you can see, it works on a linter level, but doesn't really work on a interpreter level. So as you can see, annotations are just hints, but on the other hand, these hints we can use to create APIs. And yeah, let's do it. Let's create our first API. So first of all, install Django Ninja with pip like so. Then in some new module, import from Ninja API class. And then we need just 3 lines. So first of all, we initialize our API instance. Then we use decorator. In this case, we use api.get to implement the get method. And inside we pass the path for that operation. In our case, it's /add. And finally, we pass the request to our function. This is just the common Django approach, like all view functions, actually first argument are request. As you can see, it's not even needed to mark request with type annotations, but if you want to, you always can. The rest stays the same. A and B will be integers, and the result will be the plus between A and B. And finally, just put this API.urls to URL patterns, and that's it. You already have a ready API, and all you have to do now is to go to /API/docs, and there you will see the ready-to-use graphical interface and both documentation for the API you just created. So in our case, you see we have here the method /API/add that accepts two arguments A and B. They will be passed in get parameters, and let's try and execute it. And there you go, we get our results. So A and B are passed as get parameters, and we got our result. But unlike before, our type annotations are now enforced. So if we pass, for example, not a number to our B argument, we will get a HTTP error that our B argument is not a valid integer number. So basically we have now a guarantee that whatever we define in our functions will be always guaranteed and enforced. And we don't have to worry about serialization, validation, and displaying the error messages back to the clients. And of course we can return any type of results. So before we were outputting just a number, but we can actually return any structure that is convertible to JSON. It can be dict, it can be list, it can be any object that can be converted to JSON. And as well, like before, our arguments were passed as get arguments, but if we use mustache brackets in our path, we can mark them to be passed in path arguments. So here, if we query the same URL with /add/3/4, yeah, we get our result as valid number 7. What other methods we can do? It's actually pretty straightforward. So to send a post request, we use .api.post. To put, we write .put, delete, and so on. So yeah, pretty straightforward. All popular HTTP methods are there, and you can even use your own or combinations of multiple methods to define your APIs. But where it mainly shines is when it comes to more complex JSON payloads that are submitted by clients. And the main horse here is a class called schema. So let's create a new example where we will be creating blog posts with payloads. So all we have to do now is to define a new class that is inherited from schema, and we can define there like as many as possible, as complex as possible arguments. So it can be ints, dates, a list of strings. These are just standard Python. There is nothing import here. There is nothing new. You basically define with annotations what you expect, and the framework guarantees that you will get your results like you defined. And now all you have to do is in your post endpoint, add an argument which have annotation new post. And yeah, there is a helper method dict that can convert your object into a dictionary. And yeah, let's see how it works. So this is our request body example. And what you note here is, for example, year we pass as a string, and a timestamp we also pass as a string, but as noted before, we expect their year as a number and timestamp as a date. So now if we execute this request, this is what we get as a result. So yeah, you see the year is correctly converted to a number, and timestamp is also converted to a number, but yeah, it's actually in JSON we don't have dates, but yeah, believe me, it's actually a date. But what's really cool about the way we use annotation is that when we use them, the editor can actually know what argument it is. And as you can see here, our timestamp is a date parameter, and once we type a dot, we can already use autocomplete to find the method that we need or the attribute that we need, and yeah, we never need to make any typos or mistakes. So As you can see here, VS Code even suggests that, yeah, we made a typo here and we should better change it. So the more type annotations you use, the less errors are in your code. And schemes also can be used to filter out unwanted data. Like here, if we pass some extra suspicious attribute, it will not be present in our validated payload. By the way, Ninja automatically generates OpenAPI spec for all defined endpoints, which means you can use a lot of third-party tools like Swagger UI that I already showed, or Redux that also comes as an option. Or you can even generate client-side code that will be automatically up to date with the changes that you make on a server side. And what about performance, right? So there's probably a big penalty for all this fancy validation. Well, actually no, and the opposite. Well, according to some tests in comparing with Django REST framework, Ninja schemes can be sometimes like up to 2 times faster in data parsing and validation. And also you can use async views, and more importantly, you can mix sync and async views in one project. So endpoints that are waiting like a lot of I/O can run in one async worker, and the CPU heavy task can run in multiple sync workers. Now, in previous example, we used schema in request body, but sometimes we can have a ton of arguments in get parameters, like tens of optional filters that are passed in URLs. Like in this example, we can define our filters as query set lookups and pass it as a function argument. And the only extra here, we need to tell Ninja that it should be taken from query instead of body. To do that, we can import this query marker, which will tell to get the data from get parameters instead of the body. And yeah, here to skip parameters that were not provided, you can use this exclude unset argument. And yeah, finally just send all the lookups into query set filter, and that's it. And yeah, the same way we also can access cookies and header values. You can define them like so, and as well get all the validation you define. Working with files is as easy. You just have to set your argument with a file marker, and a resulting value will be a standard Django file object with all the necessary attributes. Well, if you need a list of files, it is as easy. Just set this argument with a list container. Now, responses, right? So sometimes outputting nice results are as hard as parsing the data. Let's take an example, the following database model. So yeah, this is a blog post with a bunch of fields. And now we need to output list of these posts. All we have to do is define a post schema with the same attributes as the fields. And here we just set the same types annotation that matches the database fields. And we set this class as a response attribute to our endpoint. Now if we check the interactive docs, yeah, it defines all the results correctly with all the attributes. And when we execute it, we are getting all the items in a way we define them. Oh, and did you notice, like, our endpoint just returned a query set? Yeah, there is no need to convert to any other intermediate dictionaries or list or anything like that. Just one line of code. And also it is as easy work with nested objects. So if, let's say, our blog post have a foreign key to some category model, all we need to do is define category schema and just use category annotation. And it will be automatically queried from the database and serialized. And one of the simplest features is pagination. All you have to do is add this paginate decorator. By default, it is limit offset paginator. If you open our interactive docs, yeah, we now see pagination options, and when we execute it, yeah, the results we have, yeah, so this is our current page of items and the total number of results. Next is schemes and models. All right, so creating schemes for models is nice and intuitive, right? But what if you have like tens of fields in a model and these fields are constantly changing during development? Well, we have a special schema called model schema. With model schema, you can just configure the model and the fields that you need to sync to that schema. Well, basically it's the same as Django model forms. Alright, and now whenever you change any fields in your model, those changes will be automatically applied to corresponding schema. So every application tends to grow, and yeah, once you have more than 5 endpoints, it's already a good time to start splitting your project into some logical pieces. For that matter, Ninja comes with a road structure. Let's take an example. So here is like a tree structure of some small project. Yeah, so there is a managed UI project and there are 3 applications, some events, news, and blogs. And each of these applications is supposed to have some API calls, yeah, at least 5 to 10 endpoints each. So in this case, what we will do is we will create for each application a new module api.py, and inside this module we import a router from Ninja. A router is basically it's having the same interface as a Ninja API class. Yeah, it have all those get, posts, and all the rest of functionality. So what you do is basically you inside each API module inside application, you define as usual your endpoints, and once you're done inside your main module where you create your main Ninja API instance, um, you can include those roles from different modules using the add router method. And yeah, in this case, like all the endpoints that were defined in events router will be included to main API, and all the path will start with /events. The same for news, all the news endpoints will start with /news, and same for blogs. So this is the way you can easily split your application into multiple independent modules and include them and even reuse if needed. Also keep in mind that Ninja API instances are also pretty independent. So you can, for example, have some public API in one Django project, and in the same project you can have some private API, and yeah, you can even have multiple versions of the same API, and they will be all independent and will have their own URLs and routes. I started this project about 2 years ago, basically as some proof of concept with just 400 lines of code. And as of today, please consider it a production-ready library. It is 100% covered with tests, it has constant code reviews, bug fixes, and it is already used by more than 10 companies, the names I know of, and I know it's a lot more for sure. So yeah, if you use Django Ninja, yeah, please drop me a line. And also, yeah, as of today, as I see on stats, on a PyPy, the package has more than 50,000 downloads per month, which to me sounds like really crazy. And also, I would like to take this opportunity to thank all the contributors who helped with the project. Yeah, I never thought that the open source project you spend only like 1% actually writing the code, and yeah, the rest is way more work. And yeah, if you have any ideas or PRs, yeah, please don't hesitate. Thank you. And the easiest way you can help this project is to go and hit that star button on the GitHub page, because yeah, this will bring it to explore page, then more people will come and more people again will click the star button, and yeah, they will keep rolling. All right, thank you for having me, and if it's technically possible, I hope I will answer your questions. Thank you.